All right. Hello, everybody. Today is Wednesday, September 6th, and we are here for ES 2110 statics. And we are going to just spend a little bit of time working through the material that we are covering and just going through the schedule, making sure nobody has any questions. And then I want to remind you that there is no synchronous class on Friday. So there are recorded lectures and you'll just watch the lectures and keep up with the schedule, but I will be off campus that day. So we're gonna just have a day of relative rest and relaxation. So if we take a look at our schedule, where we are right now, takes a while to get down here. Today, September 6th, we are talking about lectures 6 and 7. And then on Friday, when I will be off campus, we'll be doing 8 and 9. So when we meet again on September 11th, which is Monday of next week, we will be back face-to-face or Zoom. So you have that option for a synchronous instead of asynchronous component. And homework 2 will be due, which will cover the first 2 chapters. And then quiz number 1 will be due on Wednesday. Now remember, the homework is just hand in through Moodle, like we did with the conversion factor handout. And on chapter 2, which is about the statics of particles, all of your textbook is available to you, and you've got the lectures to watch. And today, of course, we're doing 4 and 5 or 5 and 6. I'll take a look in just a minute. We'll talk about it. And then we have some other problems to do. But when we get down to the submission, you just submit this homework assignment as usual. But a week from today, on Wednesday the 13th, there will be a quiz. And I just want to remind you, you'll open the quiz here, but you'll take the quiz on engineering comp paper, and then you'll scan your quiz and submit it here. So I just didn't want to have any surprises to anybody. There always seems to be somebody who submits through here, and it works. It acts like it's submitting, but it won't grade properly. So, so make sure that you submit just in the same way that we've been submitting assignments. And the whole thing from the time you open the quiz until you submit the work will be 1 hour. So it doesn't cut you off, but just make sure that you're careful about that time limit, because I'll check the timestamps and we'll move forward from there. So I'm not like picky if it's like 2 minutes or something, but just don't leave it open for 4 hours. We would have to talk, and that would not be what we want to do. All right. So today we are on lectures 6 and 7, which when we come down here, you can see that we're talking about chapter 2, and it's section 2.3, basically, in our textbook. So I just wanted to cover a few things about section 2.3. But before I do that, I want to see if there are any questions at this point. About homework, about material, about quiz coming up, about anything at all. No. All right. All right, very good. So we'll take a look at section 2.3, and then, like I said, make sure I have some lecture notes here for section 2.2, and then we'll cover 2.3 today, and then of course we'll move on to 2.4 actually on Friday. So, and then we'll talk about it on Monday. So away we go. All right, so section 2.3, and it is posted, of course, to the Moodle page as well. Let me get my stuff out here. It's easier if I just take this apart and put 2.3 up and start talking about it. 2.3 is the last section before we get heavily into 3-dimensional reasoning. And so 2.3 talks about tension in cables and forces being borne in members and sort of the directionality of that, and adds to that the idea of the summation of forces in vector directions, adding up to zero in order for a particle to stay still. Okay. In other words, when it says forces and equilibrium in a plane, plane means two-dimensional, generally speaking, X and Y, and equilibrium means not moving, which means the summation of forces in a vector direction, which is always equal to mass times acceleration. For equilibrium, acceleration is equal to zero. So that means that the summation of forces in a vector direction are equal to zero. So in the past, we've broken forces down into X and Y components. And now we just take this following step, which we've done a little bit because we haven't gone into the graphical solution methods, but we take all of the X directional stuff and add it together to be zero, and all of the Y directional stuff and add it equal to zero. Now it's possible to do other vector directions other than X and Y. And you may have worked in the past with different coordinate systems, but X, Y are referred to as Cartesian coordinates after Rene Descartes. And we'll start out working with those, and we'll spend a great deal of time talking about Cartesian coordinates as well. So let's just take a look at what the homework assignment is for section 2.3. And let's just pull this all together in one place and just look at an assignment. Okay, so section 2.3 begins with some theoretical problems, but basically 243, so we're right here. So problems 244 and 248 are homework problems for this section. And I have problem 244 right here, so I'm going to go ahead and work it out for you. And please let me know if you have any questions, and we'll stop and take care of it along the way. All right, so problem 244 says, two cables are tied together at C and they're loaded as shown. Knowing that alpha is 30 degrees, determine the tension in cable AC and the tension in cable AB. All right, so the tension means the force directed along the cable. So you could express it as an XY component, or you could express it as just a magnitude at an angle. And either of those is equally as good. I prefer to do it in XY or IJ components, just because it lends itself into three-dimensional stuff a little bit more easily. The other thing we want to talk about is what is the difference between tension and compression. Tension means that you're pulling on a wire, and compression means that you're pushing on something. Okay. And the interesting thing about this is that certain substances behave differently in tension than they do in compression. For example, if we look at our two cables here, you can see that if we pull in this direction, they're going to bear that load until they break. However, if you push on in their cables, they're not going to do much of anything, right? You're just going to squish into the wall. In the opposite sense, concrete behaves very well in compression and is terrible in tension. So when we get into mechanics of materials, we're going to learn lots of ways that we compensate for making sure that our load is transferred in such a way that we're never asking concrete to bear a tensile load. But here, the first thing that we have to do is to determine how to draw a free body diagram, or just the forces. All right, so the first thing is, in AC, what does that force look like? And in CB, what does that force look like? Well, the answer is, it's going to, in both cases, be pulling. So this is BC, and this is AC, and this is the 6 kilonewton force, which is purely X. All right, So this is actually almost the entire full body diagram. We're told that this angle is 55 degrees. And we're told that this angle, which is identified as alpha, is 30 degrees. Okay. So how do we know that these forces act like this? Well, if they acted like that, once again, it would be pushing and the cable will not push. So we know that they're pulling in this direction. That also tells us that AC is going to be negative in the X direction because it goes from the right to the left, but positive in the Y direction. And BC is negative in the X and negative in the Y. So start by doing these two equations of equilibrium. We start with summation of forces vector equals 0 for equilibrium. And so we know summation forces X equals 0 and summation forces Y equals 0. This is kind of like where you always start. Okay, what do we have going here in the X direction? Well, we have a positive 6 kilonewton force because X is positive this way, Y is positive this way. That's a convention. Every now and then there will be a case where it'll be easier for you to choose it differently. But if you don't have an excellent reason, always choose X positive to the right, Y positive up. All right, so 6 kilonewtons is positive, but the AC component in the X direction is negative because it pulls to the left, as does the BC component. And those are the only three X-directional forces acting on the connector right here. So those three things will add to 0. All right, what about in the Y direction? Well, all we have is a positive AC in the Y direction and a negative BC in the Y direction. This has no Y directional component. So it's just these two things are equal to 0. All right, so now let's talk about what is BCY. We know that this angle, this is BC, hypotenuse of a triangle, 30-degree angle. So in this case, BCY is equal to the entire force in BC times the cosine of 30. And if we do AC, we see that this is 55 degrees. So similarly, we see that AC in the Y direction is going to be AC times the cosine of 55 degrees. Now, one thing we can see here, we have two unknowns and one equation, so we can't solve this directly, but we could solve for either AC or BC. We could see AC, for example, is equal to BC times the cosine of 30 divided by the cosine of 55. And this is just a number, right? So we can punch in to our calculators what that looks like. Cosine 30, divide that number by the cosine of 55, and that turns out to be 1.51. So AC is equal to 1.51 BC. Now this is going to come in handy when we substitute into the other equation, because we still have the same two unknowns. We have one more equation, so two unknowns, two equations means we can solve this system, but we don't know what it's going to look like yet. All right, first of all, we rewrite this equation, 6 kilonewtons minus ACX, using the same triangle. ACX is AC times the sine of 55 degrees. And now for BC, BCX is BC times the sine of 30 degrees, and that's equal to 0. So if I bring the two terms with variables in them to the right-hand side of the equation, I get 6 kilonewtons equals AC times the sine of 55 plus BC times the sine of 30. Now we still have two unknowns, but now we know that AC is equal to 1.51 BC. So we can substitute that in for AC and write the equation. 6 kilonewtons is, instead of writing AC, I'm going to write 1.51 BC times the sine of 55 plus BC times the sine of 30. And at that point, I have two terms, both with BC in them. So I can factor it out. I got 6 kilonewtons equals, I say BC times quantity, 1.51 times the sine of 55 plus the sine of 30. So I can find out what the numeric value of that is. Oops. It's not a calculator than your phone. All right. So if I take the sine of 55 degrees and multiply it by 1.51, and then add to that the sine of 30, I get this parenthetical quantity is equal to 1.737. So I get 6 kilonewtons equals 1.737 times BC, or I can then say BC is equal to 6 kilonewtons divided by 1.737. So if I take the reciprocal of this, oh no, don't do that. There we go. We just want the reciprocal, which is right here, and multiply it by 6 kilonewtons. And I get BC is equal to around 3.5 kilonewtons. Okay. Now the real numeric value is quite a bit. I have a lot of decimal places, 3.45439. So I'm going to keep this value in when I solve for AC. I'm not going to hold all the decimal places for my answer, but just for that intermediate step, I'm just going to multiply AC by this number. And so I get that times, excuse me, I'm going to multiply 1.51 times that number. And I come out with 5.2. So that gives me 5.2 kilonewtons is equal to AC. Okay. And those are both tensions. They're drawn as tensions. If I had gotten a negative sign on either of these, it would indicate that I had drawn the sign wrong in the original picture. But since they came out to be positive values, they're both tensions. So that's an accurate answer. I could have broken this down into I and J components, but really when they ask for tension, it's more applicable to just write the value and then recognize that it's directed along the cable or along whatever's bearing that load. Right. Do you have any questions? All right. Well, very easy to get along with. So that is it for today, ladies and gentlemen. Keep working through chapter 2. Even though I won't be on campus on Friday, I will be available by email and text. So if you have any questions, let me know. I won't have my book with me. So if you have the problem and you take a picture of it from the textbook, then you send it to me either through email or text. I can help you right away. And I think you're going to do just great. And I'll see you on Monday and we'll pick up where we left off. All right. Have a wonderful day. Recording stopped.